Welcome to another episode of Insight, the show where we dive into the works of various individuals in the fields of science and technology. As you may have seen, previously on Insight, we had presented to you researchers from the world of nanophysics to mechanical engineering to telecommunications. In the studio today, I have with me Dr. Muhammad Ahmad, who is currently working as a research fellow at the Advanced Techonolgy Insitute at the University of Surrey. Dr. Ahmad has a PhD from the University of Surrey, MPhil from the University of the Punjab in Pakistan, and a Master's in Physics from Government College University, Lahore, also Pakistan. Amongst his numerous skills are CVD growth of carbon nanomaterials like graphene and carbon nanotubes, and device fabrication using various cleanroom techniques. He also has experience in developing lithium-ion battery anodes and electrochemical sensors. During his research, Dr. Ahmad has raised the graphene CNT growth standards at the University of Surrey from their basic level to one of the most advanced levels in the world. Before we speak to him, let's take a brief look at a day in the life of Dr. Muhammad Ahmad.
I'm Dr. Muhammad Ahmad. I work here at Advanced Technology Insitute, University of Surrey, and I've been on this position for last 6-7 years. I did my PhD from the same institute, and my area of research and expertise are to grow carbon nanotubes and graphene using chemical vapor deposition and using low condition growth system. So let's go inside. I'll introduce further that what I'm going to do today in the labs. I have planned to do carbon nanotube growth today in plasma lab, and also to do some thin film deposition using clean room facilities. So let's go inside. So next in my today's schedule is to work in this lab, which is called plasma lab, and this is actually dedicated for the growth of carbon nanomaterials. So I'll go into this lab. We are in this plasma lab here. Here we have a number of equipments. This is the only system which is active. So let's start this system, which today I'm planning to work on. So before I come here, I just check the system health. Is it in working order? So it is in working order. I just start the pumping down process so that I can put my samples inside the chamber, right? So I just wait for the system to end. We have various gas lines which are used to grow carbon nanotubes and graphene. So I just turn on the relevant gases which are required for my process. These are just copper discs, and the aim is to grow carbon nanotubes on these copper discs. So after venting the chamber, I'll open this lid, load my sample inside this chamber. And here we can see the configuration here. We have in this optical head, optical lamps, which deliver the optical energy from top to the top surface of the sample, which is here. So this one is just a silicon wafer. So this is the copper disc where I want to grow carbon nanotubes. I'll just put inside. So after closing the lid, I just want to bring the chamber into high vacuum condition. So here, this is computer controlled machine. So we can just press one button, which is called pump, and it will bring the whole system into high vacuum condition, which means that the chamber may be hot a little bit from inside. So we just need to be a little careful. Although we can read the temperature here, which is 192. So I think it's okay to open the chamber. So here we can see growth has occurred. It's not very good growth. So these are two samples, which is ungrown sample and this is grown sample, and we can clearly see the color difference. This has become black, and this black color is because of the growth of carbon nanotubes. So next in today's plan is to go into this lab, which is called clean room. So just open and go inside. So this is changing area where we need to wear some oversuits so that we can't take the dust and other particles with our dress inside the this clean environment. After wearing these shoes and taking all the care, we come inside. So whole this area is controlled, and we can just start venting this machine so that we can load our sample in. This side of area is called yellow room. So this is even higher in cleanliness in terms of the particles. So this one is a silicon wafer where we have printed our pattern on it, and using this photolithography technique, and we can see that it contains the metal connection as well as some features for the electrodes here. So I'll show you in the middle of this area. There are a number of small holes of various sizes, which we have printed using this technique. And I'll put it into the machine which I have set for the evacuation, the load lock chamber. I'll load this wafer inside this machine. So it is automatic system here. As I close the lid, it started pumping down automatically. And this we just define a recipe here, that what we want to do, and it will just start the processing according to our recipe. I've just defined the conditions in this recipe to deposit my first target, which is aluminium. And once the system is in ready state, I'll start the process. So I just start the process, and we'll see this vapor being moved from this chamber to this chamber. Okay, so we have done the deposition of our catalyst, and this sample is ready for the growth of carbon nanotubes. So now we are going in our microscopy lab. So the purpose to go into this is to use the scanning electron microscope so that we can see whether we have done the growth of carbon nanotubes on our sample, which we did today. So here we are, this one is the scanning electron microscope, and here just we want to vent the chamber first, this one to open its gate, and then we can load our sample inside and start doing the imaging. So here we just want to prepare our sample to load inside the chamber. Just load our sample here, and I will just tighten this screw a little bit. So this is an electron microscope, which is very powerful tool to see nano scale items. We can't see with using the optical microscope. It is like thousand times stronger, and we can see very high magnification using this microscope. So this tiny sample here, we can see the copper disc we have just loaded, and we just want to bring it nearer to the gun. And this is just raising the stage to get closer to the electron gun. So what we are seeing in this image, some nanoparticles as well as carbon nanotubes which are just lying around horizontally. So what I could understand so far, the growth is not vertically aligned, just tangled and horizontally network of CNT are grown, as we can see from this image now. This is the one of the day or routine day which I normally work, how I normally work at ATI. So some of the activities are here, but they are not all. Different days, different planning, different projects require different utilization of equipment. So normally these are the labs where I work. So this is one of the day how I work in the ATI.
Viewers, as you have just seen there, a short introduction into the professional life of Dr. Muhammad Ahmad. At this stage, you may now be wondering, what exactly are carbon nanomaterials? What's so special about them, and what impact could this material possibly have on me? Well, let's find out by speaking to the man himself. Dr. Ahmad, first of all, welcome to the show. Thank you for being here. Let's start off with carbon nanomaterials. So what exactly are they, and what benefit could they have on myself or somebody on the street?
Thank you very much, Mudassar, for having me today. For regarding carbon nanomaterials, I would start from element which is carbon. I think we all are well aware of carbon, and we are well aware of its two major forms, which are diamond and graphite. And the only difference in these two materials are the atomic arrangement of carbon inside these crystalline materials. Until past, we just were aware of these two materials, but now with the advanced scientific research, we have discovered many more materials which are actually in a nanoscale, and these are graphene, carbon nanotubes, fullerenes, so these type of material. So the difference between these nanomaterials is that one is that they are at nanoscale. Nanoscale means that if we see that 1 meter and 1 centimeter, 1 millimeter, then 1 micrometer. So 1 nanometer is actually 1,000 part of 1 micrometer. So in that scale, we are seeing the structure of these materials and study their properties. Being nanomaterials, their properties are different from their bulk materials. For example, if we extract one layer of graphite that is called graphene, this has a ballistic conduction in that, but in graphite, the conductivity is with respect to its bulk properties. Similarly, being carbon in both materials, diamond and graphite, we can see the huge difference in their properties. Diamond is the hardest material known, and graphite is softest one, right? So these type of things are there. So with the nanomaterials, we see that there are very fascinating properties which are attracting research for various applications.
And so with nanomaterials, what sort of impact could this material have on us in the future?
I think it will change the silicon-based technology to carbon-based electronics and devices, which will eventually be low-cost, flexible, and reachable to every person in the world.
So in terms of this as a subject, nanomaterials, what sort of subjects or grades would a school or college student require to get into this field?
Both chemistry and physics are relevant at the GCSE and A level for students. And the more important thing is that the students' personal interest. If they want to come into this field, they should have interest right in the beginning. Maybe after GCSE, they should first know themselves that this is the area they want to go in, and they just focus on that and do struggle to come into this field.
And so we know you yourself specialize in carbon nanotubes. Why did you decide on this particular subject for yourself?
At that time, after having done my MPhil, which is in microelectronics engineering and semiconducting physics, and having physics as my background, I was just discovering what are the novel areas, and these CNTs were recently discovered in 1991, and were a huge amount of research were being done into this field at that time. So this was kind of a hot topic for me, and I was very much interested to know more about this. So this actually brought me into that research in carbon nanotubes.
Generally speaking, one could say we often look for solutions to address particular problems or issues. Were there any pre-existing problems or issues that your research was trying to address?
Yes, certainly. Every project in research have some difficulties and challenges beforehand, and we were actually looking for solution. And we do propose some solutions and seek for funding to address those, to carry on the research. So I have done various projects during my research career, and the first one, which was the PhD one, was actually related to the interconnects in integrated circuits. So interconnects are the just metal wires which carry the electrons or current from one point to other point. and currently we use copper and conventional materials to serve this purpose. But at that time, CNTs were actually being considered that actually they can function better than copper because they are having very high current carrying capacity, 1,000 times higher than copper. So my main area of research was actually to explore whether carbon nanotubes can be used as an interconnects in IC industry.
And in terms of yourself or your colleagues, your team members, have you ever experienced any sort of scientific breakthrough or any sort of eureka moment within your research?
While we do research, we come across actually new findings almost in every project, and those findings, if they are important and significant, we want to tell other scientific community by writing peer-reviewed papers that we have found this. So that in that point of view, I have around 10 publications so far in high impact factor journals. But if we say that a turning point, like the discovery of carbon nanotubes itself was a breakthrough in the material science. So not that type of discovery I have seen in my group.
And again, going from the general public's perspective, are there any practical benefits or applications that your research may ever end up providing for the general public?
Yes, certainly. I think that because these new nanomaterials, carbon-based nanomaterials, are being explored to replace existing silicon and hard materials from the industry, and there is a kind of success so far as well. So they are being implemented in many areas now. They will reach to the publics in near future. Some already have reached in certain forms. For example, we have seen carbon nanotube based rackets and bicycle frames which are there. But we are also seeing some huge kind of arrival in the biomedical science and other sensors, electronic devices.
Okay. Thank you, Dr. Muhammad Ahmad, for sharing your insight with us. And now we will move on to the next part of the program where Dr. Ahmad will present some of his research to us.
I am Muhammad Ahmad, and I am a research fellow at Advanced Techonolgy Insitute, University of Surrey. My main area of research is carbon nanotube based electronic devices. And these carbon nanotubes, actually carbon nanomaterial comprise carbon nanotubes and graphene. Telling further about what the carbon nanomaterials are, I would refer to the famous allotropes of carbon, which are diamond and graphite. Although these two materials entirely contain carbon in it, but because of the atomic arrangement of carbon, they are entirely different from each other in their properties. Diamond is the hardest material, whereas the graphite is the softest material. Diamond has no electrical conduction, it's insulating with respect to electrical conductivity, but graphite is electrically conductive. So all these differences are because of their atomic structure. Graphite has the layers of carbon atoms, hexagonal arrangement, and these layers can slide on each other. If we separate a layer of graphite, then that single layer will be called graphene. That is just one layer of carbon atoms, the thinnest material which we know so far. If we roll that thin sheet of graphene to form a cylindrical structure or tubular structure, that will be called carbon nanotube. And the diameter of carbon nanotubes normally range from 1 nanometers to 50 nanometers, and their length can be from 1 micrometer to maybe half a meter so far. So because of these different atomic structure, carbon nanotubes acquire different properties and very interesting properties actually, which make them suitable for a range of applications. Some of the properties of carbon nanotubes are that they are electrically conductive and have very high current carrying density, greater than copper. They are flexible material, they are lightweight, and they are very strong as well. CNTs can be single wall or multi-wall, and they can be semiconducting or metallic CNT. Semiconducting CNTs can be used to replace current conventional semiconductor materials from IC industry, and metallic CNTs can be used as a conductor for electricity. So because of these excellent properties of carbon nanotubes, they have a range of areas of application. Some are shown in this slide. They can be made as a wearable implantable devices on body, electrical wires. In energy sector, they can be used in energy generation and also in storage, and they can be used as a flexible substrate. CNT-based devices can be made on flexible substrates, and there are a range of other applications of CNTs, composite material, aerospace, automobiles. It's a range of a lot of properties of CNTs are there. Regarding the growth of carbon nanotubes, there are mainly three techniques which are used, which are called arc discharge method, laser ablation, and chemical vapor deposition. Chemical vapor deposition is a preferred method for CNTs to be used for electronic devices because they can be used in predefined areas, and there many parameters can be controlled in CVD which can't be controlled in other techniques. We are interested to grow carbon nanotubes at a relatively low temperature, and this slide shows some of the methods which are used in CVD to grow carbon nanotubes at relatively low temperature ranging from 350 to 500 degrees centigrade. At Advanced Techonolgy Insitute, we use a photothermal chemical vapor deposition system, which has an optical heating system to deliver optical energy from top right on the catalyst, and the substrate containing catalyst is put on the water-cooled chuck. In this engineering arrangement, we have a temperature gradient where the top surface of catalyst reaches to the high growth temperature, whereas the bulk remains at low temperature below 450 degrees centigrade. Some of the projects have been working where CNTs are employed are shown in this slide. Recently, I've been working to use carbon nanotube-based electrodes to detect COVID-19, where the DNA or RNA for COVID-19 is amplified using a technique called LEM, and then mixing with other reagents and using carbon nanotube-based electrodes, we can do some electrochemistry testing to make a sensor for the COVID-19 virus. Similarly, CNTs have been growing to be used as an interconnect in integrated circuits. These interconnects are actually called vias, which is vertical interconnect access. We are able to grow carbon nanotubes on full 4-inch silicon wafer, and the importance of this growth is that we can actually remove these CNTs to be used on another material which can't tolerate high temperature conditions in chemical vapor deposition. Similarly, we have demonstrated carbon nanotube growth on copper foil, which was actually used to develop an anode for lithium-ion batteries. And we have also worked in the area of graphene and solution-based graphene to develop a touch sensor, as we can see here. So this was just an overview of some of the work we do at Advanced Techonolgy Insitute with respect to carbon nanomaterials.
Thank you so much for sharing your insights with us and our viewers, and for sharing your golden nuggets of professional advice. We appreciate it.
My pleasure.
Viewers, as you saw there, scientific research covers a vast array of topic areas and subtopics, each with a plethora of applications to address real-life issues. This brings us to the end of our program today, and I hope now, like me, you are also a little more enlightened into the wonderful world of carbon nanotubes. Do join me next time for another episode of Insight.